Hello everyone. So previously we had discussed on the topic KD trees algorithm, k-dimensional trees algorithm, right? So today we'll be discussing on the topic Morse algorithm for the trees, right? So let's see what the definition part say here. Morse algorithm is a square root decomposition technique. So this is very important. What it is a square root decomposition technique used to efficiently answer multiple range queries like sum, frequency, etc. on a static array. So it reduces query complexity from big of q into n to approximately big of n plus q into square root of n, right? So let's move on with the explanation part here. So let's move on with this step by step. Suppose we have n elements, right? Suppose we have n elements and q range queries, right? Suppose we have n elements and q range queries. Each query asks for some result on subarray L, R, right? A brute force approach, what it does, it recalculates the result for every query. It recalculates the result for every query, right? So it would be the overall time complexity would be big of n into q. What does the Morse algorithm do then? Morse algorithm reorders the query smartly using square root of n block sorting. Square root of n block sorting, right? So consecutive queries have overlapping ranges. So consecutive queries have what it contains actually. It had Yeah, so that the queries have this one overlapping ranges. Sorry, we adjust our range by adding or remove elements. What we do, we adjust our range by adding or removing elements at the edges to compute each query efficiently, right? Let's see the steps here. The exact same steps we will be uh, we'll be making use of exact same steps actually, right? So the same thing will be articulating in the form of code in simple terms. Yeah, so the let's move on with the first step. What we will do first, we will divide the array indices into the blocks of size square root of n, right? First we will divide the array indices into the blocks of size square root of n. Next we will sort the queries first by block number of L, then by r value if both belong to the same level. Yep, so this is one of the things. The third one, so we will be maintaining the current range, nothing but the current left, current right, and current answer, right? So this is the thing. First by block number of L, then by right value R value if both belong to the same block. Third one, maintain the current range, current L, current R, and the current answer, right? For each query, what we'll do, we'll expand or shrink the range, update the answer accordingly, right? So that's what we'll be doing. The exact same thing will be articulating in the form of code or whatever the steps that we discussed now, right? So let's go with the example problem to implement the Morse algorithm. So the given problem or the problem is, given an array, we have to answer q queries where each query asks for the sum of elements between indices L and R, right? So let's start writing the algo here. The first thing we'll be making use of the math operation. So I'll just import math here, right? So this is fine. Let's write the function to implement the Morse algorithm. So I'll just go with Mo algorithm. Yep, so this is fine. So I'll just go with array as well as the queries as parameters, right? So this is fine. So within the Morse algorithm function or the method, main method, so what we'll be doing actually it's a function, right? So we're not going with the class. Anyways, so let's go with the total number of elements in the array. So I'll just go with length of array. Yep, so this is fine. Next one is let's go with the number of queries. So q equals length of queries, right? So I'll just pass the queries. Third one here, I'll just consider the block size as well. Let me initialize this one to them. So we'll be going with the math operations here, nothing but the square root, which we have to go with the square root of n, right? So I'll just go with, this has to show why this is not showing actually. Yep, square root of n. Yep, so this is fine. The next part, so we have to first thing here accordingly with the steps, we have to divide the array indices into the blocks of size square root of n. Initialization part is over. Sort queries first by block number of L. So let me do one thing now. I'll just go with queries here dot sort. So I'll just set the key to lambda here. This is fine. X. So let me go with here. X of 0. this is fine by, let me go with block size here, block size comma x of 1, block size x of 1. So this is fine. Next step, we have to initialize the count at the, sorry, current range and the current sum. Also, we have to store the result for each query. For that one, we'll be making use of the result variable. First, let's go with the current L, current R, current sum. Let's initialize all the three variables to 0. Then we can initialize the result variable actually. I'll just go with current L. Let me go with the current R, sorry, current R, and let me go with the current sum as well. Sum, let me initialize this one to the 0, 0, and 0 respectively. Let me initialize result, resulting variable res initially into q. So this is fine. Yep. Now what we have to do, accordingly with the this one explanation part, we have to process each query, right? For each query here, we have to process each query, right? For each query, we have to expand or shrink the range, and we have to update the answer accordingly. So that's what the explanation part says here. So we have to process each query first. For loop for I in range. What's the range here? Q, right? So this is fine. So within the for loop, let me assign L and R to queries of I, right? So to iterated value of the query. So this is fine. Next, we have to move left index to L. Let me write the simple while loop here. While current L, if it is less than L, then what we need to do, first we have to remove the element going out of range, meaning I'll just go with the current sum here. So current sum equals current sum minus array of current L, right? So I'll just go with current L. So this is fine. The next part is current L. So this is fine. Current L equals current L plus 1. Yep. So this is also fine. Next, let me go with one more while loop here, right? So let me go with one more while loop here. So this one will be current L. So if it is greater than L, then what we will do? So I'll just go with the current L. So this is fine. Equals current L minus 1. Yep. So this is fine. Next, let me go with the current sum. This one, current sum equals current sum plus array of, I'll just go with the current L, right? So this is fine. Yep, we are just adding the element coming into the range. Yeah. Now let's do one thing. So we have to do the same thing for the right index to R, right? So first what we did, we are moving this one left index to L. That's what we did here, right? So I'll do the same thing for the right as well. Let's move the right index to R. So let me come here. So let me paste it over here, right? So again, so this one, if the current R, the current R, if it is greater than R, if the current R is greater than, sorry, we have to check for less than or equal to, right? Less than or equal to R, then what we have to do, we have to add the new element into the range, right? So current sum equals, right side we are considering, right? Current sum plus array of, instead of the current L, I'll just go with the current R. Yep. So here current R equals current R plus 1. Yep. Next, let's move on with the next step actually. I'll just consider current R. If it is greater than R plus 1, then as we are going with a right one, right? So I'll just go with the current R equals current R minus 1. So this one, I just have to change this one to R. Because current R minus 1, this remains same. Current sum equals current sum minus array of current R actually. Yep, so this is fine. Next, what we need to do here, we have to store the answer for this particular query. Nothing but it will be stored in the resulting variable res. Res of I equals, let me assign this one to the current sum. Yeah, finally what we have to do, let's return the result. Yeah, we have to return the result, nothing but for loop. So this one I'll just go with return result. Yep. So yeah, let me come out of this one entirely. So what shall we do? We are done with the algorithmic part. So I have explained you this one step by step. So initially we discussed this one step by step, right? Within the explanation part, the exact same thing we have articulated in the form of code, or we have implemented in the form of code. Now, For the interactiveness, let's do one thing. Let's go with the example usage or the demo usage. Usually I take it from the Google. Let me take the example usage or the demo usage from the Google. Just give me a second here. So I'll just come here. Let me paste this one over here. So I have considered the array here, right? So I have considered the array here. This is fine. Uh, Now I'm considering the queries as well, right? 0 to 1, 3, 2, 5, and 0, 5 with the ranges, right? So this is fine. We are running the most algorithm here. So what I have considered here, 1 second. Yep, let me copy this one. Let me paste it over here. Now error should be gone. So this is fine. Array comma queries. We are just passing the array and the queries with the values, right? So this is fine. So we are just printing the output just for the interactiveness. I have made use of the print statement. Yep. So now, as we are completely familiar with the code that we have written, let me run the code. So I'll just give here Control J, Python followed by the file name.py. Yeah. So the output that we are getting here is sum equals 6, sum equals 9 for the query, this one 2. For the query 3, we are getting sum 21. For the query 4, we are getting sum 18. Right. So here, see, first query, see, accordingly with the output. So let me explain you this one. We are getting the correct output actually 6, 9, 18, 21. Right. So whatever the code that we have written works absolutely correct here. So let's consider the first query here. First query we have 0, 2. Yep. First query we have 0, 2 here, right? So elements in the range 0, 2 are, so this one 0, 1, 2. Let me give the index here 4, sorry, 4 and 5, right? So what are the elements in the range 0 to index 0 to index to 2 actually 1, 2, 3 are in the range 0, 2, right? So they have given range. Queries is nothing but the range, right? So this one is fine. Yep. So this one is fine. Let's move on with the second one. Second query. Second query we have already discussed this one. Let's go with the 1, 3 actually here, right? For the 1, 3, what are the elements that are in range actually? What are the elements that are in range? This one, 1, 3, right? 1, 2, 3 we have to consider. 2, 3, 4 actually elements. 2, 3, 4. So this is fine, I believe. Next, let's move on with the third query here. Third query, what's the third query? 2, 5, right? So 2, 5, we have to consider from 2 to 5, right? So 2, 2, 3, 4, 5. 3, 4, 5, 6 are the elements we have here, right? So I'll just go with 3, 4, 5 as well as the 6. So finally we have the last one here. Finally we have the last one, nothing but 0, 5. Yep, 0, 5. So I'll just go with here 0, 5. So this one, 0, 5 means entire thing from 0 to 5. So this will be 1, 2, 3, 4, 5, 6, right? So 1, 2, 3, 4, 5, 6. So we have to go with the value from the index 0 to 5 means 1, 2, 3, 4. What are the values? 5 and 6 accordingly with the example that we considered within the elements in the array, right? So now what we are basically going with, we are going with the sum, right? So algorithm, what it does, it calculates the sum actually for the query 1, query 2, query 3 and query 4. So sum up this one, all the elements 3, 4, 5, 6. Yeah. So first, for the first one, see here we have got the output 6. For the second one, see here 4 plus 3, 7, 7 plus 2, 9. For the second one, we have got the answer 9. See here this one. For the third one, we have got 21. Let's check. So we have to go with 6 plus 5, 11. 11 plus 4 is nothing but this one. 15. 15 plus this one is 18 actually. 18, right? So 2, 5. Yeah, we have to get 18 itself. Sorry. Yeah, so we have to get 18. So this one is considered actually uh, post query. This one actually we have to get this one step ahead, right? So this is fine. For the 2, 5, it has to be 18 itself. So finally, from 0, 5, it is 6 plus 5, 11, 11 plus 4, 15, 15 plus 3, 18, 18 plus 2, 20, 20 plus 1, 21, right? So 6, 9, 18, and 21 we have to get, right? So the output. So here in this case, query 1, query 2, query 3, 6, 9, 21, 8, 21 and 18. Because so this one 0, 2, it is considering 0, 2, 1, 3, 0, 5 and 2, 5. So order doesn't matter here, right? So this is fine. So we are getting the desired output. We are getting the desired output. So whatever the algorithm that we have written works absolutely correct. Most algorithm works, or the code works absolutely correct here, right? So we are getting the desired output. So this is it for the algo actually. We have discussed the coding part step by step. So we have discussed the output part as well. We have got the desired output based on the code that we have written. Now let's do one thing. let me summarize whatever we have learned so far. There are some 4 to 5 points actually. We have to know this one at any cost. The first one, most algorithm, what it does actually, most algo, what it does, it efficiently answers multiple range queries. I'll just write here multiple range queries on static arrays. So this is important, on static arrays. Most algorithm efficiently answers multiple range queries on static arrays. So this is the first point. Let's move on with the second one here. It uses a square root of n, actually square root of n block sorting, square root of n block sorting to reduce the redundant computations. This we have discussed and we have to know this one at any cost. Let's move on with the third point here. What's the time complexity? We have discussed the time complexity. It's bco of n plus q into square root of n, actually into square root of n. So this is going to be that this is the time complexity for the algorithm that we have written. The fourth point here is the space complexity. Space complexity is big of n plus q, right? Space complexity is big of n plus q, right? So the time complexity for the code that we have written would be big of n plus q into square root of n, and the space complexity would be big of n plus q. And the final one, it is best used for the offline queries. So this one actually use cases. So it is used in the offline queries. Mainly it is used in the offline queries known beforehand, where updates do not occur between the queries, where updates doesn't occur or do not occur between the queries actually. Yep. So this is fine, I believe. So these are some of the points I wanted to discuss with you guys actually. These are very important points and you have to know this one at any cost. Yep. So I hope whatever the code that we have written, I mean algorithm, is completely clear, right? Yeah. So this is it for today. So we are left with only two algorithms. We are done with almost 114 algorithms actually. 112 algorithms we are done with, or 11111, right? So we are left with only two algorithms. One is meet in the middle algorithm, and the last one is it's related to the bit manipulation, nothing but the algorithm's name is subset enumeration, right? So these two algorithms we are left with. Let's complete that one tomorrow. Yeah, we are done with the algorithms. As I've said, we'll be discussing around 120 algorithms. Actually, there are some 5 to 6 algorithms I found it like it was not necessary actually, in the sense it was not necessary basically. Primarily, it was not necessary. So I removed that one. So we have discussed 114, or we will be, as I said, we will be discussing 114 algorithms. We are done with 113 actually. We are done with 111 algorithms. So tomorrow we'll finish off this one entirely, right? So tomorrow will be going with the last two algorithms actually. Yep. So for today actually, we are done with the most algorithm. Yeah. So I hope the whatever that we discussed is completely clear, man. For now, this is it. Thanks for watching, guys.